All right, everyone, it's Miss Osterberg here. You can't see my face, but we're going to use the document camera to take some notes on the greenhouse effect. Okay, what I need you to do is get a sheet of paper, like a big notebook paper, and put it, instead of this, put it like, what do we call this, hot dog style? Put it hot dog style, okay? If you want to have the, like this is where the binding can be for your notebook, and then this would be the outer page. And what you're going to do is you're going to make, we're going to make Earth right here. So we're going to make a line here, and then a line here, and this is our Earth, okay? So take that out. This is our Earth, and we are not going to be fancy about our land, because who has time to draw all that stuff? So we're just going to call this land, and maybe we'll make a bigger land area right here. So this is also going to be land, okay? Land and land, that's what we have. And then let's add some clouds to our sky, because, you know, why not? So here's some nice fluffy clouds. Okay. And we'll do some more clouds over here. Okay. So we have land and we have clouds. And then we're also going to need the sun. So let's put the sun over here. And why don't you pause it? Why don't you pause it right now and let everyone get this drawn in their notebook so far. So please pause it until people have it in their notebooks. All right, we are going to follow the path of the sun first here. So if you saw in that greenhouse effect FET, in that last tab, in that part 3, you saw that visible light, so solar radiation, comes down onto land, onto things, right? So this is the ocean right here. I guess we'll do this too. This is the ocean. We'll put ocean right there. That's the ocean. And so we're going to draw a line from the sun to the land, okay? From the sun to the land. Try not to touch the clouds. I should have drawn it over here a little bit. Try not to touch the cloud. So this is from the sun to the land, and this is going to warm the land. So that's going to warm the land. So we're warming the land. So we're drawing it from the sun to the land, and we're warming the land. Okay? Warming the land. Okay. And then, since we're warming the land, so right here, number 1, this is solar radiation. So solar radiation is absorbed by the land, because land is going to have a low albedo. It's darker. I'm going to say, put it in parentheses there. So solar radiation is going to be absorbed by the land. I'm trying to make it bigger for you guys. Solar radiation is being absorbed by the land. It's warming the land right there. Okay, it's warming the land. And so a lot of times solar radiation comes and it warms the land. And then, of course, there are other times when solar radiation is going to come down, and instead of warming the land, it's going to get reflected. it's going to get reflected. Okay, because even though it's dark in parentheses, sometimes it's warming it, sometimes it does get reflected, okay? Because there are parts of the land that are that have a higher albedo. So for this one right here, number 2, so that's number 1, that's number 1, that's number 2, right? There's also solar radiation that's reflected by the land because it has a high albedo. Okay, so sometimes it has a high albedo, sometimes it has a low albedo. So the sun can do both of those things. You can have solar radiation that's absorbed by the land, and it just goes right on the land and it warms it. And you can also have solar radiation that is reflected because some land has high albedo. It's going to be light. Okay? It's going to be light. And so that gets reflected. That gets reflected. And then again, you can pause this so that people can write things down. All right. And if you need to pause it there. All right, so you have those two things that can happen. It can be absorbed because it has a low albedo, it's dark, or it can be reflected because it has a high albedo. And then the other thing that can happen is that sometimes, do you see these cloud things right here? Sometimes clouds, they also have high albedos, right? So clouds can also reflect solar radiation. So I'm going to draw another line down here and here. Clouds also can reflect. So 3 right here, okay? Solar radiation can also be reflected by clouds. So I'm going to put it over here. Because they are light, okay? They're going to have a high albedo. They're going to have a high albedo. So sometimes they can get reflected by the clouds because they have a high albedo. So again, you can pause this. You can pause this. Okay, so let's move over. So solar radiation comes down and it can get reflected, it can warm the land, clouds can also reflect it, okay? When it gets absorbed by the land is also giving off IR radiation. So the land is also giving off IR radiation. So let's turn to this guy right here, okay? And let's turn to this area right here. What you have is you have greenhouse gases that are in our atmosphere. And these greenhouse gases have always been there, and we want them to be there because we need them to be there. If you look here right now, some of it's warming the land, but a lot of it's getting reflected, right? So we need this to keep the heat in so that we have a warm land, okay? And so what we're going to do first is land can give off land is going to give off IR radiation. So IR radiation from Earth is reflected, okay? And also, because clouds, right? Clouds are white. Sometimes IR radiation goes up to the clouds and then it gets reflected back. So IR radiation also can get reflected back to Earth because of the clouds. So IR radiation from Earth is reflected. We can see that in number 1. So this is natural process. IR radiation gets reflected from Earth, okay? And then also, if you need to pause it here, IR radiation is also reflected back down to Earth because clouds have a high albedo, so they're going to reflect back down. So if you need to pause it here, pause it here. And if not everyone got that, pause that here too. Okay, so this, and as you can see, I didn't write any greenhouse gases in, this is our atmosphere right here. I didn't write any of the greenhouse gases in here yet. Well, the greenhouse gases, some of the greenhouse gases that are in our atmosphere are going to be CO2, so carbon dioxide, methane, CH4, and we're going to name these on another page in a moment here. And then also, a lot of people don't think about this, but H2O is a greenhouse gas, okay? CFCs are greenhouse gases. And so is something called a nitrous oxide. So I'll put him here, NO2. Or I'm sorry, there is an NO2, but we want N2O is the greenhouse gas. We don't want nitrite, we want N2O, which is nitrous oxide. My bad. So we have these greenhouse gases here, and there's lots of them, and they're all over this, right? They're all over this. I'm just writing them right here. And what they do, which is the third thing we're going to write down, is so IR radiation leaves from Earth. That's taking our heat away. Here we have a reflection that's bringing heat in. But also what can happen is IR radiation can hit a greenhouse gas and get reflected back as well. So they can hit all of these greenhouse gases and they can get reflected back into the Earth as well. So number 3 here is IR radiation reflected by greenhouse gases. I know that's a lot, you guys. We're almost done, I promise. Let's pause this right now if you need to copy that down. Okay, so let's look at this whole thing right here and kind of talk through it a little bit. So we have solar radiation comes down. Some of it's going to warm the land. Some of it's going to get reflected. Okay, so this is heat leaving. This is heat coming. Some of it is never going to even reach our atmosphere, our land, because it gets reflected by the clouds. And then also at the same time, and this this IR stuff is happening at the same time as this. This solar stuff is happening at the same time as the IR stuff. I'm just splitting them up, okay? But this stuff, if you notice from the FET, this was the red stuff going up. This is radiation coming from land. So the land is warm, it's giving off radiation, so it gets reflected from the earth, so this is cooling. And then clouds also can keep our IR radiation in. And then greenhouse gases keep our IR radiation in. And we need these gases to be able to do that. Our issue now, what we're going to be talking about in climate change, is that we have too many of them, okay? And so that's our biggest issue. And so we are going, I do want to note one thing on here. Do you notice the clouds? Do you notice how clouds reflect solar radiation, but they also reflect IR radiation into us? So I do just want to put a note on here. Oh, and we can call this, I forgot to name this, we can call this the greenhouse effect. We can call that the greenhouse effect. It's probably good to have a title on this page. So let's do a note here. Clouds reflect solar radiation the same amount as IR radiation is reflected back to Earth. So that's here, and that's here. So that's here, and that's here. And that's the note. Okay, so you can pause that. You can pause that right now. All right, so if you have any room on this page, feel free to put what I'm going to put on the next slide on this page, but I have a feeling you do not, because I wrote all over it. I'm sure you did as well. So the next thing that I'm going to show you is I do want you to write down what the major greenhouse gases are and their percentages. So most of our greenhouse gases are carbon dioxide, 79%. And then methane is 11% in our atmosphere currently. Nitrous oxide is 7%, and CFCs make up 3% of our atmosphere. And we talked about these. Remember, these are the ones that we created, we put in the atmosphere, and they are slowly dissipating, right? They're slowly dissipating. So this percentage is getting less and less every single year. But these are the ones that were tearing apart our ozone. So pause this so that you can write that down. All right, and then the last thing I'd like you to write down is just a review of what the greenhouse, like a definition of what the greenhouse effect is. So it's a process of gases in the atmosphere trapping infrared radiation, which is heat, on Earth. So that is what I would like you to write down for today. I know that's a lot. I know it's right before Thanksgiving break, and you guys have been troopers. Hopefully you have all turned in this assignment. This is due today, okay? There was a reading on this. Oops. There was a reading on this that you had to read. I believe it looked like this. It was in this. And hopefully you got 20 minutes to work on that today. That was my hope. And then we did notes on this for the remaining time. That is all I have for you today. What I would ask is that you not take your cell phone until 2 minutes before the bell. and that you find something to do. If you want to game, that's fine. But I don't want you back in the lab areas, and I want you to stay in the room. Remember, 1 hour at a time in the bathroom, that sort of thing. Be respectful and kind, and have a great Thanksgiving.